Very, very, really interesting stuff. Now, how were they used? Okay, this is one of my solutions. Let's talk about it step by step, how I did this with the model. I've got a service management layer up here. I've got an order processing center. Someone from IBM wants to order Metro Ethernet service from AT&T, classic idea. There'll be a service layer there that will send a RESTful web service, JSON XML, into a controller. And what they do is they've got what they call stateless rules. And what those rules allow it to do is to decompose what the request looks like and decide what happens to the request. It handles a process queue. You'll start to see things in the Linux world, JMS topics, GMS queues, and that sort of thing. This is where the process queue is basically a traffic cop. It'll hand off to a process MDB where there'll be some rule processing done here. Now, over on the right is where, in the telecom world, we talk about inventory and provisioned inventory. I've got stuff, and I have to figure out how that stuff is wired together. So that unified inventory could literally live in 10 different systems. I've got to figure out how I'm going to get it all together. I've got to unify it all. In addition, I've got to figure out, with what we're calling a topology engine, what the topology of the network looks like. So what we did, and again, I'll probably have a slide that covers this, we said, this is way too complex for a relational database. In concert with, I'm being told, these damn Oracle licenses are too much, please get me off Oracle. Okay? So I live in the world where when I propose an Oracle license solution, they tell me you better be able to make sure I'm making money off this because the licenses are killing me. So I've got the money problem and I've got the technology problem here. So we took the unified, the topology engine and unified inventory, and we moved over to a graph database. All we did, we're a research shop, we did research. We said, what's the best way to do this? What's the one product we can prototype with that will give us a solution we need in the time we need it? Which was about a month to get this all done. We looked at all the other graph database vendors, and the only ones that really allowed us to be productive, prototype right away, and get the throughput we required was Orient. And Venus makes me laugh. She said, the reason why she found me was I wrote a review online about what I thought of OrientDB. And if anyone ever reads my reviews, they know I do not give good reviews. I'm not the kind of person you want to have to write a review for you. It was the only product I said, I turned it on, I downloaded the community version, I got the database up and prototyping, I handed it off to the development team, and in about 7 days we had the database implemented. That's virtually impossible anywhere else. So the productivity, the throughput, and the ability to be productive right away was there. So we implemented the inventory engine and topology engine in about a week. They gave us a month. So we had to figure out all the other stuff in the month. How are we going to process the rule engine? How are we going to handle the orders coming in? Those RESTful web services, those REST interfaces was how we really did it. And the reason why is because my element management layer down here, this could be a different product that's turning the boxes on, turning on the Cisco equipment, turning on the Alcatel equipment. It's a completely separate system. I've got to tell them somehow, the order people, what the order looked like when they were done. So by the very nature of the way the business is, I've got to deal with multiple applications all talking to one another all at the same time. And you really don't want a monolithic solution anyway. So we looked at Orient, we went, shoot, this stuff works. And we tried it out, and we go, wow, look at this. The prototype actually is giving us throughput. We showed this off to our customers, and they were like, wait a minute now, you guys are kidding me. Like, the throughput we were getting before was terrible, and now you're telling me I have milliseconds wait time? And we're in the Wall Street area. There's a central office right around this area that Verizon uses. I mean, you can take a guess how many orders that one central office gets in this part of the country. They get 100,000 orders a day. 100,000 orders per day, just for, you name it. I want data services, I want voice services, I want something to happen where data goes from point A to point B. That data center has 100,000, that one single data center, 100,000 orders a day. This is where they're handling it. The throughput is there, and we saw it right away. So I do this for my software developer people. I like to use patterns when I do my designs. So we decided that the best way is go back to the classic MVC model. The database is the model. We have people dealing with controllers, dealing with the APIs to talk to the database, and our front end is nothing more than a session facade, that view. So that MVC pattern saves us an unbelievable amount of headache. And the model can be multiple models and multiple controllers with multiple views, which is what we were doing. So very, very classic MVC model here, nothing crazy, okay? Some of the areas we're focusing on. We talked about the ordering. There's an area in telecom called fulfillment and an area called service assurance. Fulfillment's sole purpose in life is, how can I get my orders in? How can I get them completed? How can I get the equipment turned on? And how can I bill and get paid? That's what fulfillment is all about in the telecom world. Get the order done, get it completed, get the equipment turned on, get that customer up and live, because the minute you do that, you start billing for the service. Now, service assurance is really about, how can I figure out what's going on in my network? How can I make a request, a query of some kind, over multiple layers across multiple geographic areas, and how can I get my answer back quickly? That was the cherry on the sundae for us. Because when I handed the interfaces to the Orient database over to the service assurance people, they were shocked at the throughput. The fact that they could make these requests across multiple networks, autonomous systems, and things like that. So when we get back to this picture, I was hoping this was a little bit bigger. Maybe I have it bigger, I'm not really sure. Let me just make sure. No, this is the only one. That's the picture. So you're gonna have to squint. We process an order here in one area of the country, and this UNI is the network interface for the user. We needed to take this piece of equipment, and we needed to connect it all the way across the country to this remote terminal over here. Now, if you look closely, and again, sorry about the resolution, there is a simple ring, there is a bus, there is a star, there is a ring, there is a bus across the country, and there is a kind of a little tree here. It's simple. So what that tells you is I've got to go across multiple topologies, multiple equipment layers, multiple layers of services, and multiple kinds of technology. Maybe I've got to go over, God forbid, copper, right? Or maybe I'm going through fiber, or maybe one of those links is a microwave station and a microwave, or maybe a satellite uplink and a satellite downlink. So I've got to go across these networks, and the vertices need to be having properties. The edges need to have properties. And what we haven't really talked about yet is, how do you handle capacity and consumption of that capacity? So there's lovely algorithms built into the database. And they said, well, it's going to take us a month or so to figure out what a Dijkstra algorithm would do for us. And I went, funny you should say that word, because the Dijkstra algorithm's built into this sucker. And we weighed the edges, and we were able to make that connection in about, a matter of seconds, and which is unheard of, absolutely unheard of in most worlds. So we were very impressed by it. We compared Orient versus Oracle. It wasn't even close. It really was. The case study was, we loaded 10,000 records into the Orient database, and we saw a minimum of 20 to 30% throughput rate improvement. That's conservative. It was at times almost double. But I don't like to say that because I can't do it consistently. Yes?
Well, why do you think? Why do you think that happened?
I have a performance graph, and I can explain exactly, if I use the graph, why I think that happened. Okay? So we'll hold that question to that. What that says is, the document model, right? I talked a little bit about graph. I got to squint. My God, we have to squint, don't we? The document model that we did was, I have physical people driving trucks around the country, and they've got to go to the site, they've got to open up the data closet, and they've got to wire something up. They have no idea what they're looking at. So we have something called wiring instructions. And when the wiring instructions are paired with standards of the box that they're trying to turn on, like how does this thing actually work, and how are you going to wire it up? So we used a document model for that. So what I should have started with was, I told you what the past was, which was relational databases, the present, the graph database, and our future is really going towards things like this, where we're using a combination of things in this model that we have in OrientDB. We have graph, we've got documents, which is, again, if you squint real hard, it says field instructions, right? How does equipment get terminated? How does the metadata get related? Can this be optimized to different data formats? This means that I've got a field technician with some mobile device, Android, iOS, whatever the popular OS is. So we don't just throw a document at them. We've got to format it into readable text for them on the mobile devices. So these, what we're calling tech access devices are actually accessing the database and pulling the documents out of the database and merging them together in a displayable format. Okay? We change them dynamically based on the field tech. If we know that the tech is an expert in fiber, we make sure that they don't get non-fiber instructions. That's also helpful. So the database allows us to determine what kind of instructions to produce and what kind of document to produce. And the object-oriented world, and I apologize for the font here, this is my way of explaining how I used object-oriented. Is I created some equipment. The equipment became a shelf, and the shelf became Cisco equipment. So I used a parent to a child to create this extends from V, the vertex object that Colin talked about earlier. And then we extended that vertex object to be equipment. Equipment extends to shelf, and then shelf extends to Cisco. And then finally, the geospatial model, which I have a graphic for to try to explain this. The graphic I showed earlier was the 2G, 3G, 4G wireless model. In my world, 5G's taken over. If I had to say what the future of telecom was, it's 5G, because it's gigabit Ethernet transmission rates. The only problem with the gigabit Ethernet transmission rates in the telecom world is that your distances are very limited. So what they're creating is these, what they call 5G dots. It looks like about the size of a smoke alarm. And they're mounting them up on the poles. You don't even notice them. It's just these white dots kind of up on the pole. And they transmit very, very high speed over very short distances. So we said, hey, why don't we do this for our research? Why don't we go into New Mexico and Texas? And this is the Permian Basin where the oil fracking is being done. And the locations of where the drill sites are very remote. So our research is doing now is we're going to create a network of 5G dots, 5G radio transmitters, and we're going to daisy chain them back all the way through the network. And so this network of 5G dots are not only going to communicate what's happening at that oil driller, but it's going to actually be able to transmit that data backwards. So it allows you not to have to pull cable, not to have to put a satellite transmitter up, and it's pretty cool stuff. So like I said, my whole world now is in 5G. And Internet of Things, the IoT, it can literally be anything. They're coming up with all these different crazy new ways of using 5G. Yes?
How do you think that'll impact, cable has kind of dominant right now?
Good question, good question. Verizon has stopped deploying Fios fiber optic cable deployments. There is no need to pull fiber to your home any longer. They're going to put a 5G IoT dot outside your house, and they're going to have a radio transceiver in your house, and they don't need to even do a drop wire across the street to your home.
Wow.
So there'll be no need to do that any longer. And the only place you put fiber is where you've got heavy-duty backhaul. So what does that mean to my cable friends, right? And their coaxial cable with their high loss. I'd be very worried if I were them right now, right? Because this 5G, I mean, there's no joke. And they're only now starting to put it in the lower 48. And I think I was explaining earlier to some of my friends, the overseas market is in its infancy. They really don't see a need this kind of data rate because the 4G networks in those countries are really self-served. This really is the US. So I'm going to see a lot of 5G trials coming up. Yes?
Where's that coming online?
Right now. Right now.
It's one dot per house, so not going to tip up on neighborhoods?
What happens with the dot usually serves about 4 to 5 homes, and they're cheap and they're low power, and you can just pop them around. You really won't see these gargantuan cell towers any longer.
They put them on telephone poles?
They do. They put them on telephone poles. Yeah, the existing telephone poles. Sorry?
Solar?
And solar power. Mm-hmm. Yep. Exactly. That's how they do it. It really is the wave of the future. Yeah, I think once, and again, our phones right now, they have the radio antennas for the 5G, they just haven't been turned on because there's no network to connect to. Right. You know, and the SIM cards and all the technology it's been in the phone forever. And you can imagine how easy this is to have like your car be a 5G car. Yeah. You know, it's really pretty cool stuff. The problem with 5G is it doesn't penetrate concrete, so you have to have them, a lot of them. But they're small and they're cheap. So yeah, it's a really interesting market to be in. It really is. Sorry? Woohoo, Ericsson, woohoo, Ericsson, woohoo. Ericsson, woo, I have a job. Yay, I still have a job.